All right, guys, we want to talk about the paired t-test. This is going to be different than the independent two-sample t that we've been working on so far. So to get started, let's consider the question, why not just use a two-sample t-test? Okay, so why do we even need this other test called a paired t? So let's consider the following shoe wear data. So each person wears an Adidas and then each person wears a Nike. And we measure the tread wear on the Adidas and we measure the tread wear on the Nike. And we do this for 10 people. And so that's the data that we're seeing in front of us right now. All right, we want to test the hypothesis that these two shoe brands provide the same results on average. All right, well, we know how to do that with a two-sample t-test. We can set up our null and our alternative hypotheses. So there, our null would be just assuming equality. All right, so that mu1 equals mu2, or mu Adidas equals mu Nike. And then our alternative that they are not equal. All right, so can we find a p-value? Yes, we can, and I gave you guys the data, so we can go over to Minitab. All right, and so here in C1 through C3, we have the data that I just gave you on Adidas and Nike. So we go into two sample T, put in Adidas, put in Adidas, put in Nike. All right, go under options. The default is not equal to, so we're fine on the alternative. It doesn't matter right here whether we assume equal variances. Let's just not assume equal variances for right now and say OK. And we get a p-value of 0.735. So we go back over to our PowerPoint here, and we get a p-value of 0.7375. Okay, so what's our decision going to be? All right, so we've got 0.7375. How does that compare to alpha of 0.05? All right, so clearly our p-value is greater than alpha. All right, and so when the p-value is greater than alpha, what is our decision? Exactly, we fail to reject the null. All right, so what's happening here is that we cannot conclude that the two shoe brands differ on average. Okay, so in other words, we ran a two-sample t-test and we did not find a significant difference. All right, what's wrong with this? What's wrong with the two-sample t-test? Well, what's wrong is that we did not detect a difference. Okay, so the problem is we're picking up differences between people and we're picking up differences between shoe brands. Let's go back for 1 second. Bear with me. All right, so let's go back to our data and think about what I'm saying. Not only are we picking up the Adidas Nike difference, so the difference may be between the 1.2% and the 1.24%, but we're also picking up the difference between person 1 and person 2. All right, so let's think about this. Do we want the difference in how people wear shoes, or do we just want the difference between how Adidas and Nike shoes wear? All right, so we've got a problem with the two-sample t-test. Okay, so again, we're picking up differences between people and we're picking up differences between Adidas and Nike. We want to conduct a test that excludes or ignores the variation due to people. We don't care that people wear shoes differently. We only care about, is there a difference between Nike and Adidas? All right, so let's go through this considering using a paired T. How is a paired T difference? Well, again, we've got our data in Minitab. We've got our people, we've got the Adidas wear, and we've got the Nike wear. What Minitab is going to do in the background, so again, let me stress that one more time so you don't think this is something you have to do. This is what Minitab does, okay? Minitab calculates a difference between the Adidas and Nike for each person. So here's the first person's difference, the second person's difference, the third person's difference, and so forth. And so we get an average, a sample average of just the difference, okay? All right, and we want to test the hypothesis that these two shoe brands differ. These two shoe brands provide the same results on average. Now, we've got one sample statistic here. Okay, so think about before with the two sample t-test. With Adidas, we would have a sample average. With Nike, we would have a sample average. So we would have a mean for Adidas, a population mean for Adidas, and a population mean for Nike. But now we have condensed that into one difference column. And now we only have one sample statistic, so a sample statistic of the difference that is going to be part of the distribution for the population mean difference. All right, so notice how our hypothesis test is changing. It's no longer mu Nike equals mu Adidas. It's now the mean difference equals 0 versus the mean difference not equal to 0. Okay, so again, notice there's one population parameter here, not two. All right, and you're going to hear me say that over and over again before the second exam. All right, so let's go to Minitab now and find the p-value. All right, so we go over to Minitab, and again, we've got our data in here. So what's changing? What's changing is we go to two sample paired t. All right, each sample is in a column. Yes, it is. We put in Adidas and we put in Nike. We go under options, specify our alternative. Our alternative is not equal to 0, so we say OK. And we scroll down, and again, see here, with Minitab, it's telling you, okay, this is a paired t. We've got one population parameter, and that is the population mean difference. We ran a two-tailed test, and we get a p-value of 0.0319. All right, so let's go into PowerPoint, and we found our p-value to be 0.0319. So let's think about what our decision's going to be. All right, so again, the p-value is 0.0319. Our alpha is 5%. So 0.0319 is less than alpha. So now what is our decision? Exactly, our decision is going to be to reject the null. And so now we do conclude that the two shoe brands differ on average. All right, so now we do detect a difference. All right, so why do we now reject the null? All right, for independent samples, the p-value is 0.7375. Why is the p-value so big? Because we're picking up more variation or uncertainty. It represents two kinds of variation, people and brand. All right, in the paired t-test, the p-value is 0.0319. It only represents one kind of variation, brand, which makes the test more sensitive and allows us to pick up a difference. All right, so what are the advantages of using a paired t-test? Well, we remove the effect of variation between the people. All right, we increase the sensitivity or power of the test so that we were able to detect a difference. All right, and so that again, we detected a difference between Nike and Adidas with the paired t-test, whereas before, with just the two independent sample t, we did not detect a difference. All right, so here's the million-dollar question. When do you use a paired t-test? So on the homework, when I mix up all the different two samples, so you've got two sample t and you've got paired t, how are you going to know to use a paired t-test? All right, you have both populations within each test subject. All right, so again, let's think back to what this Nike and Adidas data looked like, okay? We had a column for the person, we had a column for Adidas, and we had a column for Nike, all right? Telling us that each person wore both shoes. That's what it means for both populations within each test subject, all right? So sometimes this looks like measurement, intervention, measurement. So an example of this is the good old-fashioned before and after treatment. So maybe we measure your weight at the start of a program. We put you through a 30, 60, or 90-day weight loss intervention, and then we weigh you again. That would be a measurement intervention measurement or a before and after. That is very classic paired T. All right. Another one would be matched or paired observations. That's what we saw with Nike and Adidas. They were paired or matched on the person. Okay. All right, and we want to use a paired T when we want to remove the variation between test subjects. So again, we're not interested in how people differ, or at least with the shoes, we were only interested in how the brands differ. All right, let's consider an example. And this one we're not going to do in Minitab. We're just going to think through it and think through why this should be a paired T. All right, we want to compare 20 tires of brand A with 20 tires of brand B. We do not want to consider the difference in cars. So we know cars wear tires differently. We don't care about that. We're only interested in comparing brand A to brand B. All right, so we're going to use a paired T-test. We put each brand on each car. What would this data look like in Minitab? You would have a column for the car, so maybe cars 1 through 10. You would have brand A wear column, and then you would have brand B wear column. All right, and then we would combine the results across the cars, so we would just be looking at the variation between brand A and brand B. All right, another example. We want to compare 10 appraisals from company A with 10 appraisals from company B. We do not want to consider difference in values of houses. All right, so we don't want to compare the houses, we only want to compare the appraising companies. All right, so we use a paired T-test and let each company appraise each house. Okay, so again, what would our data look like in Minitab? We'd have a column for the house, so maybe houses numbered 1 through 10. We would have the appraisals from company A, and then we would have the appraisals from company B. All right, and then we would combine the results across the houses so that we would only be picking up the variation between company A and company B. All right, let's consider another Minitab example with a paired T-test. The lab wants to compare 2 methods of testing chemical concentrations across the expected range of a typical product. The 2 methods are visual titration, VT, and automatic titration, AT. 10 samples were tested using each method. The data in parts per meter are given below. Does this data indicate a bias between the 2 methods? All right, and we're going to use a 5% alpha. All right, so we've got our data. All right, we're going to run this as a paired T. Now, why is this a paired T? Let's take a look in Minitab at what this data looks like. So in Minitab, we see our samples 1 through 10. We see the visual titration results, and we see the automatic titration results. So a big hint here, guys, is that when it's paired T and I'm giving you data, I've got to give you 3 columns, okay? So let me say that one more time. A big hint when it's paired T is that I've got to give you 3 columns. Another hint is that the sample sizes for the data columns have to be equal, all right? Because each sample goes through the visual titration, each sample goes through the automatic titration. So there's going to be 10 visual titration results and 10 automatic titration results. All right, let's run a paired T on this data. We go to paired T, we put in the VT results and the AT results. We go under options. This is a 2-tailed test, so we can leave the alternative on the default and say OK. And we get our, we see our 1 population parameter, the mean difference, equal to or not equal to 0. And we get our p-value of 0.0220. So let's go back to PowerPoint. All right, so we've got our null and our alternative, just as Minitab had stated. Our alpha is 5%. Our p-value is 0.0220. All right, so we reject the null. Why? Because the p-value is less than alpha. All right, so one more time. The p-value is less than alpha, so we reject the null. So we conclude that the two methods give different results. Okay, so we are concluding the alternative that the difference is not equal to 0, so that the methods give different results. All right, let's take a look very quickly. Let's minimize this and minimize this. All right, so here is your homework data. Okay, and let's just look at the first two problems quickly. Okay, and think about whether these are going to be a two-sample T or a paired T. All right, number one. All right, so let's take a look at this first problem. Grand Strand Family Medical Center treats minor medical emergencies for visitors to the Myrtle Beach area. There are two facilities, one in the Little River area and the other in Murrells Inlet. The Quality Assurance Department wishes to compare the mean waiting time for patients at the two locations. Samples of the waiting times for each location in minutes are in the Minitab data file. All right, so let's go over to Minitab. Here we go. All right, location, waiting time. All right, so assume the population standard deviations are not the same. So, okay, so here we get variances are not equal. At the 5% significance level, is there a difference in the mean waiting time? All right, so here we've got two columns. All right, in our data, we've got Little River and Murrells Inlet, and then we've got our data column of waiting time. All right, so this would be a two-sample T. All right, a two-sample T. Here, waiting time is the sample. The sample ID would be location. All right, we are only testing a difference, so we leave the alternative on the default. And then it says here to assume the population standard deviations are not the same, so we would not check our assume equal variances box. All right, and that's how you would run the first problem in the homework. Let's take a look at the second problem. The president of the American Insurance Institute wants to compare the yearly cost of auto insurance offered by two leading companies. He selects a sample of 15 families, some with only a single insured driver, others with several teenage drivers, and pays each family a stipend to contact the two companies and ask for a price quote. To make the data comparable, certain features, such as the deductible amount and limits of liability, are standardized. The data for the sample of families and their two insurance quotes are in the Minitab data file. At the 10% significance level, can we conclude that there is a difference in the amounts quoted? All right, so let's look at our data here. We have each family, Becker, Berry, Cobb, and so forth. We have their Progressive quote, and we have their Geico quote. All right, this is matched pairs. The Becker family gets these two quotes. What do we want to do here, guys? We want to compare Progressive and Geico quotes. We do not want to compare families. We don't care that the Becker family's quotes are more expensive than the Berry family's quotes. We don't want that variation. So this would be a paired T. All right, another hint would be that the data is in 3 columns. I have to give you the third column of how these two columns, Progressive and Geico, are linked. Another hint to you would be that if we go back and reread this problem, never are we reading to assume the variances are equal or not, okay? So we don't get any information on the population variances or standard deviations. That's another hint that this is going to be paired T. So we would go into paired T, we would put in Progressive, we would put in Geico. Under options, we would leave it on difference because we're just testing if there's a difference, and we would say okay to get the results for the first or for the second problem in the homework. So hopefully this helps you get started on the homework. This basically tells you how to answer the first two problems, and I'll let you work through the rest of the problems.